All right, here goes. This is my presentation, which is why we might want to start type checking our JavaScript and how that could even work. So my name's Paul Morris, software developer with Thunderbird, and specifically I work on the calendar part of the project. All right, so yeah, I've been with the Thunderbird team for a little bit over a year now, working full time. Before that, I got started with Thunderbird Codebase as a Summer of Code student, Google Summer of Code on the calendar project. Event in a tab was my calendar project that I got started with a few years back. So shout out to the Google Summer of Code. All right, so just to kind of introduce and set the stage for what I'm talking about today, and kind of where I'm headed. With Thunderbird, we have a large code base. It's a very old code base. And so questions are like, how do we improve this code base over time? How do we improve the developer experience and productivity working with it? So that's kind of the overarching kind of goals here and context. And one way to do that is finding ways to leverage the computer to help us. We have these amazing machines that are so powerful and fast these days that the more work you can get the computer to do, the better in a lot of ways, if you can leverage that power. So we've had some good success in this direction already. We're now using ESLint to automatically do style checking. So we have consistent code style and catch things that are different from the code style that we want, which makes it easier to jump into the code base and understand what's going on and follow what's going on and know how to format your code, what the norms are for the project. And then similarly along those lines, we're now using Prettier, which automatically formats the code for you. And that's a nice thing. You don't have to worry about where to put the white space. It just takes care of it for you, so the computer does more work and the programmers can be freed up to focus on other things. So not everyone agrees with what Prettier does, but at least it's consistent. So so what else can we do along these lines? The next step, I think, might be type checking and automatic type checking. So that's what I'm going to be talking about today. And TypeScript as the kind of the current front runner for ways to do type checking on JavaScript code. So that's the basic background. So I thought I would start out with a little discussion of static typing and dynamic typing, which is, if you were looking for differences in programming languages and programming cultures, communities, opinions on how to do things, this might be right in the top of the list there. This is a debate that goes back a long ways, and there are strong opinions on both sides. So thought we'd just kind of review some of those to set the stage a little bit and think about what are some of the advantages and disadvantages of these two different ways of approaching types in programming languages. So first off, statically typed languages, you're talking about C, C++, Java, and then among functional languages, Haskell, OCaml, Scala, and then some more recent generation of languages like Rust, Go, Swift, and Kotlin are all statically typed, and usually statically typed languages are compiled as well. Those tend to go together. So those are some of the statically typed languages, just to kind of get that onto the board here. And then, of course, dynamically typed languages, you're talking about Perl, PHP, Python, Ruby, JavaScript, some of the more mainstream ones. And then among functional languages, there's Lisp, which goes way back, and Scheme, Racket, and Clojure, and that dynamically typed functional languages. And these languages are usually interpreted, so you don't have a compile step. They just run in an interpreter. So, and I'll try to go through this fairly quickly because I want to get to the stuff that comes later. So hopefully I don't get us too far in the weeds here, but I think it's worth to step back and think about about these things when we have moments like this virtual summit to do that kind of stepping back and thinking through these things. So advantages of static types. So one of the big advantages is that the type checker will help you catch certain errors earlier, so you can eliminate bugs sooner before they get to runtime where users will potentially run into them. You can refactor with greater confidence. So if you have, say you have a function that returns a string and you want to change it so it returns an array of strings, if you have a type checker that's doing static types, then it will flag everywhere you need to change your code to make that change, make sure that change propagates through everywhere it needs to go so that everything keeps working as it should. Whereas if you don't have static types, then you're kind of on your own to make sure that all gets done. So I think especially this is relevant for a code base like Thunderbird, where we have a lot of code and there's a lot of refactoring that can be done as we move the product forward. So having greater confidence in refactoring would be a big help there. The next item here is reducing the mental load on the programmer. So if the type checker is keeping track of the types and you've got the types codified and expressed in the code, then you don't have to keep that stuff in your head. With the dynamically typed language, the arguments to functions like variables, they still have types, but you have to remember them and you have to kind of keep it in your head more so than if they're in the types in the programming language. And you have the type checker keeping track of it for you. So that, again, is kind of letting the computer do more so that the programmers can focus on what they do that can't be done by the computer. The code stays documented and easier to understand. If you're coming into a new area of the code, or a year later you're coming back to some code you wrote, if you have the types expressed in the code, then it's easier to understand what things are and what you can do with them. And you can add comments with dynamically typed languages, but there's no guarantee that the comments will stay up to date. The code may change and the comments can get stale, and then does that comment still apply? Whereas if it's statically typed, then it's up to date. Tooling is another advantage. You see this a lot with TypeScript, which I'll be talking about later. But if you have static types, your code editor can take advantage of that for autocomplete and refactoring various things, documentation inline. That just helps out on the tooling side. And the last thing here I'm just going to mention briefly is performance. Usually you can have an easier time optimizing language with static types. That's why a lot of these are lower level, like C++ and Rust, and you can get higher performance easier if you have a statically typed language. But in this case, I don't think it's as relevant. JavaScript is pretty fast with its JIT, just-in-time compilation. So, but it's worth mentioning. Okay. So on the other side, advantages of dynamic types. They're simpler and easier for beginners. If you're starting out to program, that's just less that you have to learn all at once. There's no compilation needed. You can just run your files in the interpreter, so there's no waiting for the build step to finish. In this case, we have a build step anyway with Thunderbird, so it's maybe neither here nor there. Dynamically typed languages tend to be more concise, especially if it's a language where you don't have type inference with the static types, so you have to write all the types out. If you don't have to write the types, then it's more concise. With type inference, that gets a little less of a differentiator, but I'll come back to that at a later slide. One of the things people mention a lot is the dynamic types help you go faster, and I think that's true in the short term, especially if you're writing simple scripts or prototypes or sketches, just kind of working in a rough and loose way. The dynamically typed languages really excel there. You can just bang something out and get it done. And if you're not worried about robustness or stability over time, if it's just a kind of getting it running for now, dynamic types work well in that scenario. And finally, there's certain dynamic things, generic programming that are more advanced, using things that involve recursion and that kind of thing that may be easier to express with dynamic types than that are harder for static types to do. Okay, so moving on to disadvantages for static types. So you have compilation and build times. Typically go with statically typed languages. There's some effort to learn the type system and learn how to use it well. It's a new system you have to get fluent in and learn how to use. It imposes constraints to some degree. This is one of those things where you can see it as a positive or negative. In some ways, the constraints provide more clarity and structure and help the programmer, but it also can constrain in terms of what you can do. So that's a lot of people debate that aspect of it. With static types, there are more choices to make that you have to make sooner, but maybe before you're ready to make them, you have to decide what types things are and encode that sooner than maybe you're still figuring out the problem domain and you're not ready to commit to one approach or another. Again, that's where dynamic types are nice in that early stage when you're figuring things out and needing more flexibility. And as I mentioned before, it's harder to express some dynamic, advanced kind of recursive generic programming type things with static types. And static types can be more verbose, especially if you don't have type inference. Okay, disadvantages of dynamic types. The errors may not be caught and you may get them at runtime instead of earlier. And maybe users run into them rather than getting caught before that. So it's harder to refactor with confidence because you've got to make sure to make all the changes everywhere that they need to be made. This is kind of the flip side of the advantages of static types. There's greater mental load. You have to keep the types in your head. Can be harder to understand the code, especially if it's new code or you're new to the code base, to figure out what's going on and what things are and what you can do with them. And again, performance in brackets here, because generally it's easier to, dynamic languages tend to be slower. JavaScript is plenty fast for what we use it for, so it's kind of neither here nor there. Okay, so so that's some of the advantages and disadvantages to these two approaches. And so, like at this point in history, you wonder, well, do we have to choose? Is there a way we can have the benefits of both of these things and have our cake and eat it too? And there is a way to go about this that tries to do that, to leverage the advantages of both, and that's this approach called gradual typing. And it's the idea that you, at certain times, you want the code to be, you're just starting out or you're just building something new and you want it to be, you want to move fast and you want to keep things flexible. You don't want to commit to some things too soon. So you want that dynamically typed experience of working with the code and figuring it out as you go and kind of letting the design emerge organically in a way. Oops. Let's see. I just lost my slide. Bear with me just a moment. Let me go back to, let me go back here. So gradual typing, here's where we were, start from the current slide. All right, and now I'm gonna have to, let me make sure I got my sharing working right here. Okay, sorry about that. Hit the end button. Okay, so with gradual typing, you can start out in this dynamically typed space of flexibility and speed before you've committed to a certain way of doing it. And then as the code kind of settles, then you can add static types to kind of codify it and solidify it for more robustness and clarity, and provide some of the advantages of the statically typed approach. So this is a way to try to do the best of both. Typed Racket is a language that has kind of pioneered this in the kind of academia world, and TypeScript actually provides a way to do this as well. So we're going to see that in a minute, that you can do this kind of gradual typing with TypeScript. But before we get to TypeScript, another historical note here. I just want to kind of look at some historical trends briefly. So if you can think, historically, we had these statically typed languages like C, C++, and Java, and they kind of had, C++ in the 1980s, Java in the 1990s is when it's introduced. And then you kind of have the rise and the heyday of dynamically typed languages like Perl, PHP, Python, Ruby, JavaScript really take off and are kind of doing, having a lot of market share, a lot of people adopting them for what they're working on. You could think of Ruby on Rails or Node.js for web server software. And you might choose those instead of Java, say, at one point in history. That would have been a smart move. Whereas in the last 10 years or so, a lot of the newer languages that have gotten uptake have been more statically typed languages like Rust and Go, Swift, Kotlin. And so those languages seem to be on the upswing, and people seem more interested in what you can do with statically typed languages and some of the advantages that they have. So, so this is kind of this historical moment we're in, I think, if you can see this as a kind of pendulum, we're kind of swinging back towards the statically typed languages in a way, and more interest there. And I think part of that is, I don't know where I heard this quote, but it made some sense to me, that a type system should carry its own weight. And in the older, like even today, Java and C++ have matured and are different than they were once. But earlier, there was a lot of effort that the type system took. You had to type the types out everywhere. You had to do these type annotations, and so there was a real burden to having to have static types. Whereas languages now, almost all of them leverage type inference, where you don't have to necessarily type out the type everywhere. The type checker can infer what the type of something is just by how you're using it. And even Java and C++ now have type inference. So they've evolved over time to pick this up as well. And it kind of comes from Haskell and that functional programming world originally. But so I think this is one of the reasons why there's more interest in these statically typed languages, is with type inference, there's less overhead, and you can get some of the ergonomics of the dynamic languages, the conciseness, but still have the advantages of static types. The other thing I think is just computers have gotten faster, and compilers have gotten better, and so there's less waiting for the build to finish these days with these languages. Okay, and I think one sign of the times here is you can see these dynamic languages, they all kind of have solutions for doing static typing these days. So Python, Patrick mentioned this earlier, he's done some static typing with Python. PHP version 7 has type declarations. Ruby is going to get support for static types in version 3, which is due out at the end of this year, I think. And JavaScript has TypeScript, which is its own dialect, if you will, for static types. So you see even these dynamic languages adopting, or people are providing solutions to provide static typing for these dynamic languages. So I think that shows kind of the trend we're in. Okay, so that brings us to TypeScript, and I'll just introduce it briefly for those who aren't familiar, and then talk about kind of zooming in bit by bit here to what this has to do with Thunderbird and what we might be able to utilize here. So TypeScript, it's designed as a superset of JavaScript. So all JavaScript files are valid TypeScript files. It compiles JavaScript and does compile time type checking. So it's pretty familiar these days to have languages that compile to JavaScript, but so TypeScript kind of does that. You can compile today's JavaScript to JavaScript that will run on all browsers, but also you can have these type checking features as part of it. So it's interesting, at runtime, all the types are gone. It's just TypeScript, or I mean, it's just JavaScript left. The types get stripped out as part of the compiling. So it's from Microsoft, and they're in this phase where they're embracing open source development. TypeScript is developed on GitHub, and they've done a pretty good job of embracing the community and engaging with the community about what they're doing, and they seem to be following JavaScript pretty closely in adopting new features and that kind of thing. They're sticking pretty closely to what JavaScript does. So one interesting thing about TypeScript's type system is its structural typing as opposed to nominal typing. And what that means is, you may have heard of duck typing, which is basically the idea that, you know, if something walks like a duck or quacks like a duck, it might as well be a duck. So it's similar where you have an argument or a variable or an object. If it has the properties that you need, then you say it counts. It's valid. As opposed to nominal typing, where the name of something matters. So with a nominal type system like Java or a lot of the other static systems, you define an object or class, and it has a certain name. And even if you have another class that has all the same structure, the same shape, if the name is different, it'll get flagged as not valid. It'll be a type error. Whereas with structural typing in TypeScript, if the object has the properties that it has the same shape, has the properties that are required for this type, then it counts. It works. So that's a little closer to JavaScript's dynamic approach. So the structural typing is a good fit for JavaScript. It does type inference, so you don't have to write all the types. It can infer them from the use. So if you assign a variable if you assign a number to a variable, it'll infer that that's a number variable, and you don't have to declare it. So that helps keep the code concise. And it provides support for this gradual typing idea. By default, the types of things are this any type, which means it can be anything. And so if you use the any type, you're basically in that same dynamically typed world that JavaScript is already in. It's the same as just vanilla JavaScript. The type checker is going to let you do whatever you want. So you can start your code with any type, using the any type, and then gradually tighten it down and solidify it into the types that you're going to actually end up using. So it does have a way of doing this gradual typing approach. Some other thing, it also has some flexibility in how strict the TypeScript compiler is. So you can set it to do no implicit any, which means if you're using an any type, you have to explicitly say I'm using an any type, so that it's explicitly in the code. So you can choose whether it should flag that or not. Similarly, for implicit returns from functions or implicit this, it's a similar story. And then this last one is kind of interesting. You can set it to do strict null checks, so that if a variable is null or could be null, you have to declare that it could be null in the type system, so that that way you're tracking nullability in the types, which is another big. It's a pretty well, how to say this? Like that's a pretty that's like more strict than you might go at first, but eventually, if you can get there, it's pretty nice because you don't have these null pointer errors, which are infamous in a way for causing trouble. So being able to tell when something is null or not can be a big benefit. All right. So should we just adopt TypeScript for Thunderbird? Probably not likely, highly unlikely, I would say. Thunderbird is a project that mainly we use vanilla JavaScript and we avoid dependencies and we don't want to complicate the build system any more than it already is. And so this is probably a non-starter. However, one really interesting thing about TypeScript is that you don't have to, you can leverage TypeScript without using the language TypeScript, because TypeScript's compiler can type check vanilla JavaScript. So it infers the types. So it's already able to do the best it can to type check vanilla JavaScript. And this is what Microsoft uses. This is in their VS Code editor to type check, to do things with JavaScript so that the editor knows more about the JavaScript you're writing. So if you're writing in VS Code and it gives you autocomplete options, that's the TypeScript type inference working to figure out, what are the options here? What are the properties of this object that I can offer as autocomplete options here? So, so you can use TypeScript, the compiler, the command line tools, and the editors that are enabled for it to do type checking of vanilla JavaScript. And where the type inference comes up short, you can use JSDoc comments, and the TypeScript compiler will read the types from the JSDoc comments and use that as a way to tell what the types are. So that means, in this case, if you're using JSDoc comments and type inference, then there's no build step. You just have vanilla JavaScript with some comments in this JSDoc format. So that's kind of nice. So this is kind of an interesting scenario to think about for Thunderbird. And it's kind of what I want to focus on for the rest of the presentation here. So I realize there's, it's hard to kind of say what this is. So maybe we can call this JSDoc script. I don't know, maybe that's awkward, but like TypeScript using JSDoc comments just kind of gets a little verbose. And so what I'd like to do now is just show you what this looks like. Little demo here. All right. Let me see. Let me share my screen again. Okay, so here we go. We're in VS Code here. And I've got just a little sample file. I've got this comment at the top. It's at tscheck. And this tells the TypeScript compiler in VS Code, in this case, that I want to type check this JavaScript file. So here's a JS comment, type number, declaring this variable as a number type. Here I am assigning a number, so that's fine. But here I try to assign x to false, and it says false is not assignable to number. So it's telling me I've got a type problem here. So this is just using JSDoc comments. It's just vanilla JavaScript, and it's able to tell what's going on from that. So here I have a function divides by 2. So here you can see the a parameter has an any type, so it could be anything. But here, this is kind of showing the type inference. If I pass a number 4, we know that h is a number because it can infer that from what we have here. So that's showing the type inference at work. Okay, so here's how a function might look. This is a simple add function, adds 2 numbers together. I've declared the types here in the JSDoc. Takes 2 numbers, returns a number. So if I try to pass in a string, I get this error. String is not assignable to number. So then if I would have to fix it by explicitly converting this to a number, and then there's no problem. Similarly, it'll tell you, oh, look, you have extra arguments. It only expected 2 arguments, but there were 4. Is that something you meant to do? Probably not. Or if you have too few arguments, same thing. There is support for variable numbers of arguments as well, but this by the usual case is that you have a certain number of arguments you want. Okay, so these are just some more examples. This is pulled from the JSDoc documentation. So here I have, so this is a JSDoc comment that's using this type def declaration. So I can actually define this type Triforce, which is an object that has 3 properties. They're all Booleans. And then once this is declared, I can use this in various places. I don't have to spell it out every time. So here's a function where I'm going to use it as the argument. I just declare the type as Triforce. That's the parameter. Here it is. It knows that that's the type of that. We know that courage is a Boolean because it's coming from that property, and we know we get an error if we try to apply that to because of the type problem there. Yeah, same thing here. This is just the class syntax. You can use it for the constructor here, and then we know that this is a Boolean. These are Boolean properties here. Let's see, just another example of a type def, person with a name and an age, string number, and function for say name. So you can declare functions as parameters, or as properties rather, that way. You can also do, you can say more about a function. You don't just have to use just this kind of blanket function type, but you can type functions this way. So another interesting part about the TypeScript compiler is it's pretty flexible. So like here I have a type that's defined as a string or a number. So this is a syntax for, they call them union types. So it could be either a string or a number here. So if I have a variable y with this type, it's going to be either a string or a number is fine. And so here's a function. I'm doing something similar where I have string or number arguments. So here, if I say type of A equals number, type of B equals number, then we know that both of these are numbers and we can add them together in the math sense. If they're strings, then we know they're strings and it will concatenate them with the plus. But down here, we know there's a problem because we don't know, you can't add these 2 types together because we don't know exactly what type they are. So we have this, I think this is called type narrowing. So these if conditions narrow the type to just one of its possibilities. So the type inference is pretty intelligent in figuring these things out. Okay. Similarly, you can use this for undefined. So that works for that null. If you want to start tracking nulls as part of your type system rather than have it be implicit, that's the way that works. And then here's the any type. I declare type any here, and anything goes. So we're back in dynamically typed land. Okay. All right. So that's all I have there in terms of showing you a little bit about that. Real quickly, just to show how TypeScript is kind of taken off in the JavaScript world, I wanted to mention this. You can see this is the RedMonk programming language rankings, most recent ones. And you can see starting in 2017, TypeScript comes in at number 17 here. These rankings are based on GitHub projects and Stack Overflow answers. So it's kind of what languages people are interested in and kind of that are picking up steam. So you can see TypeScript has kind of risen up into the 9th spot here in the top 10. And you'll notice it's very hard to get into the top 10. It's pretty stable once you get into that tier. So TypeScript is pretty successful these days. So that's just one way to show that. Okay. All right, let's go back to the slides. Here we go. All right, so this is interesting. I had planned this talk before I knew this, but it worked out pretty well. I was working on the profiler to get the performance profiler to work for Thunderbird, and I came across this code with the TS check comment in them, and it turns out the DevTools team at Mozilla are starting to use this on some of their code, just in an experimental way with little bits and pieces here and there. Greg Tatum is the guy who worked on the new profiler UI code, and I've chatted with him yesterday just to get his thoughts on this stuff. And he said that, yeah, it works as advertised. He's pretty pleased with how it's working out in his use of it. This was really interesting to me. He said that Mossop has some experimental patches to generate TypeScript types from XPCOM and IDL files. So that gets really interesting because a lot of the objects that we deal with in Thunderbird are these XPCOM objects from C++ land. And so if there was an automated way to transform those to have the type information available for the TypeScript compiler, then you could really, that gets really interesting. And we already have these IDL files which kind of codify that type information. So if there's a way to translate that into something that the TypeScript compiler can understand, that gets pretty interesting. So this is still experimental, but it's interesting to know that other people out there on the DevTools team are working on it. Greg mentioned a couple tricky bits. He mentioned that the biggest blocker was the module system in Gecko and getting TypeScript to understand it without having to modify the TS compiler. So he was able to create lazy importer methods to get around this, which is a little inconvenient, but at least there's a way to work around it. And if you search for TS check on SearchFox, you can see what he's done there. Another problem he mentioned was types in the global scope. So especially where they're doing something a little different than the JSDoc approach that I've been talking about, which is, I think they actually have some files that use TypeScript syntax, this .d.ts files, to express the types, and then those get used in the vanilla JavaScript code elsewhere. But the types, if you declare them in files like that, they tend, I think, as I understand it, they're global, and so they can pollute the global scope. So it's kind of risky for a large code base and tricky for use in different scopes like Mocha tests, browser Chrome. Greg thought you could mitigate this by writing type tests. There's a new feature called TS expect error that should help with that. I didn't quite get too far into the details there with him, but that's another one of the issues that we might run into. I've kind of done some limited experimentation with this, just adding the TS check comment to some of our files. And another thing I ran into is that the type checker assumes that it's an HTML document. So if you do a document query selector, it's going to assume that that's an HTML element and not a Zool element. So it may not. That's another point of friction for us, at least as long as we've got Zool documents. So there might be ways around that. Greg didn't mention that as a problem, but that's something I've noticed. So one question here is, this works nicely if you're just doing code in your editor and getting feedback from your editor, but ideally you'd want some kind of automated continuous integration where this is getting checked on code that's being submitted to land in the code base. Greg said he had some work in progress code for this, but it hasn't been landed. There were some various issues still that they didn't want to go ahead with it yet, or at this point anyway. And the debugger team, he mentioned that they have a build step that's similar, a similar kind of thing where they're using flow types, which is flow is from Facebook. It's similar to TypeScript. It doesn't have as much uptake, but the debugger team are using those, and they have a bot on Fabricator that will post comments about patches that if it finds type issues with them. So Greg mentioned that that might be one possibility. He's thought about leveraging that code and repurposing it for doing this kind of TypeScript type checking. Okay, so to sum up this DevTools stuff, it's currently just a side project for Greg. Previously, Mossop worked on it, but he's moved to a different team now and is no longer working on it. Greg thought that it probably needed a full-time champion to really do it at full scale for Gecko, and there's no plans for that yet. But it's still in this kind of experimental phase. But there's at least interest there and some preliminary kind of work towards that. Okay, so kind of starting to wind up here. Type checking for JavaScript and Thunderbird. Again, we have a large and old code base, and I think introducing type checking would be helpful, especially if you think about refactoring and the refactoring that we'll probably we have been doing and will be doing more of as we move the product forward. Having the type checking would help with that process. We have a growing team of staff programmers. 2 new folks just joined us this week, and we have volunteer contributors. And so making the code base easier to understand and is a nice thing there, and that static types can help with that. And another way to think about this is, like, a lot of people think dynamically typed languages help you move fast, especially if you're a startup or something where you want to get the first mover advantage. Thunderbird is a very mature product, and it has a lot of, there are a lot of changes we want to make, but it's in a phase where being bug free is more important than having a first mover advantage, if you will. So in some ways, taking a statically typed approach helps to have more robustness and for a more stable code base. And I think TypeScripts, this is just kind of my thoughts on this. The JSDoc type checking has a lot to offer. There's the flexibility of gradual typing, so you can still have the benefits of the dynamically typed JavaScript language. There's type inference, so you still have concise code and things are pretty expressive. And there's less burden on the programmer to type all the types out, as in the olden days with languages that didn't have this type inference. There's no compilation, so that's one of the big negatives of this approach, so that's not a factor here. We already have a compilation step, so but at least it wouldn't add anything to it. And at the end of the day, you just end up with vanilla JavaScript with comments, and in a lot of ways, there's nothing, that can only be a good thing in a lot of ways, if the comments help make the code easier to understand and work with. And it'd be nice to be able to catch errors sooner before they get to runtime. So those are just some thoughts there of mine. I'm curious to hear what other people think. I think we got enough time for questions and some discussion. I want to just mention another kind of piece to this puzzle of trying to improve the code and improve the product. Various people make the argument you can get a little too confident if you have the type checking, and you still need tests. And I think this is kind of a separate area where we can continue to write tests, continue to improve the testing situation for Thunderbird to try to catch bugs before they hit our users. All right. And just some final thoughts. A lot of this is experimental. It's kind of maybe someday stuff we may want to move towards eventually, but may not be ready yet. I don't know where we come down on that, but in any case, I think we should start using JSDoc for our functions every time we have the opportunity, and including types for the parameters and return values, and prepare for a type checked future, because this seems to be the direction a lot of things are moving in these days, and there seems to be a lot of benefits to it if we can ever if and when we figure out some of the more difficult aspects. So, all right. These are the links that went out on the email earlier. There's some interesting related reading. And I'm happy to share that elsewhere as well. So that's it for my presentation. I'm curious to hear questions and have some discussion on this because I'm sure people have thoughts and opinions. So interested to hear what you think. All right, thanks.
Thank you very much, Paul. Let's see if we have any questions. Does anybody have anything that they wish to ask? There's not anything in the chat yet.
I have a question, if I can.
Yeah, go ahead.
Start.
Sure.
I was curious, it's very interesting, the implementation with JSDocs, especially because we already started implementing some JSDocs for new methods and then the return types. It's very interesting. I was curious I never used TypeScript, so I don't know, how does it handle when, for example, you have an integer and turns into a float or a double? Do you have to specify that, or can it handle it automatically because it's just it's a number?
So yeah, good question. So for TypeScript, there's just a number type. It follows JavaScript there. So ints and floats are all number types.
Awesome.
Yeah. So yeah.
Awesome.
Yeah.
And the other question was, you said it doesn't add anything on compilation. We don't need to implement anything during building. So we are basically, if we decide to adopt it, and it seems that Firefox is going to adopt it, we're going to rely on this primarily on a IDE base from our code editor, and not during compilation, or not even while running a try run, like launching a try build or something?
Yeah, that's another good question. I mean, I think.
Can I pipe in with an answer here?
Yeah,
we
please.
probably, if we can make it run as a task cluster task, like along lines of the linters, even do the same kind of thing with that. Have orange jobs that show up.
Oh yeah,
the way to go.
Yeah, that's kind of was my first thought. Yeah, that it would be like running the tests. This could be another part of the test suite in a way, that it would run like the linters do. So for building, it doesn't add anything, but it would be part of the test and process of validating code or testing it before landing it.
Awesome. Thank you.
Yeah. And as you mentioned, like if you're using an IDE that can understand TypeScript and use the TypeScript checker, then you get it there as well. So.
Yeah, I was wondering, and yeah, Rob confirmed that we can implement it during like a try run or something, because even today with Prettier, sometimes I miss some flags because are very minor, just error. Sometimes it just highlights red one thing and I completely miss it because it's like the code is so big in that specific method that without a try run, I would completely miss that. So yeah, that's good.
Yeah, totally. Yeah, and I think I mentioned this in one of the slides. I think the debugger tool, the debugger team in the DevTools team, they've got something set up that's a little more automatic even than a try run, where I guess they have a bot on Fabricator that will comment on patches that have issues. So if you just put a patch for review, if it has a type issue, then you'll get a bot giving you a
there's some
comment.
really neat stuff happening on Fabricator that I'd like to be able to take advantage of at some point.
Assuming we're moving to Fabricator, right?
Well,
Yeah. That's a whole nother conversation, I guess. But
yeah,
it seems like there's a lot of potential for integration there for these kinds of things, at least. So.
Very good. Do we have any other questions from folks? Or anything else you want to add, Paul?
Yeah, I don't know. I mean, I think just to kind of reiterate that, like, a lot of this stuff sounds good, but then there's just a lot of details here to work out in practice to, how this would work, especially with the XPCOM. A lot of the objects we deal with are XPCOM objects, and I don't know if it makes sense. I don't know how much sense it makes to go down this path until we have some of that stuff figured out, and that may be, larger Mozilla questions that Mozilla as a whole. Does the code base move to this kind of thing as a whole? So there's a lot of kind of. This sounds good. It works. I think there's a lot of promise here. There may be a lot of kind of hurdles to figure out before it can. And I guess one of the things Greg mentioned was like they used this with the website, the profiler.firefox.com site, and they said it worked really well for them there. That's kind of this isolated piece that they can do. So if there are parts, if there are modules or parts of the code that we're doing, there might be ways to kind of do them in isolation. But I think that, especially with the XPCOM question and the Gecko modules, kind of, it sounds like Greg has a way to work around that, but there are just a lot of question marks. So it seems like, I guess this is all to say, I think this is something we could experiment with, and maybe eventually Mozilla will want to move in this direction, and maybe we'll want to move in this direction. But it's kind of, in the meantime, I think as we work on the code, we can add the JSDoc comments and add the types in. Maybe we can even try out using this TS check in VS Code to just see what it looks like and what it feels like, and if it makes maybe it makes sense in some kind of small scale ways of using it before we jump in with 2 feet.
It might be interesting to do it for maybe the extensions API or something. Be a nice small area to start off with. There is a project somewhere on GitHub that actually does type stuff with TypeScript for all the Firefox extension APIs, and we'd have to write our own stuff for it to be able to use that with our APIs, but it's probably doable. Let's see if I can track it down again.
Yeah, that'd be interesting. I see Kai has his hand up.
Hi, yeah. A question. So if you don't add any JSDoc comments, type check will simply report nothing?
Well, I think it will. That's a good question. I think it will do its best with the type inference. And for some code, it may be able to get pretty far if you have concrete values in there. But the fewer concrete values you have, the more you're going to need the JSDoc comments, I think.
So the idea is if it only acts on explicitly added comments, then we could just say, well, we added job that checks that everything is fine, and as long as there are no JSDoc comments, the test will still pass, and only the types you're adding need to be correct. Only, yeah.
Yeah.
So can I get in here?
Yeah,
this is Patrick speaking. So I've worked on a couple of projects, not using TypeScript, but using MyPy for Python. So it's always the question of how do you go from not having type information or having just in comments to having some. How do you start? And what has worked well for me in the past is you just got to start by running it, see what it can infer. Some of the things it's going to get wrong, so you're going to have to add checking for that. You're going to add actual definitions. And then I think Kai is right. You add a job so you don't regress anything. And then you start adding more information and just keep filling it in until you cover the whole code base or as much of it as you care to cover. So I guess my first recommendation would be run it and see what happens. Don't worry about automating it until you see if it passes at all.
Yeah, that makes a lot of sense to me. And it's one of the nice things like you can kind of go file by file. If you add that TS check comment to the top of the file, it'll just check that file. So you can kind of go file by file if you want.
Yeah, that's kind of what we did with the ESLint, if I recall, or directory to directory sort of thing. But
mm-hmm. Yeah, nice. Yeah, it's interesting because like you might think that this isn't a first class use case for TypeScript and Microsoft, but because VS Code is one of their real use cases for it, and they really want the type inference to work, and they want to be able to, they want people who are just working in JavaScript to use VS Code and benefit from this kind of stuff. They seem to really be putting effort behind making this work well with the JSDoc comments. So for what it's worth. But yeah, I think like if there's a way to identify certain parts of the code base that are maybe not so tied up with the XPCOM, or kind of have their own thing, like Rob was mentioning, that maybe the extension APIs would be a good place to start and just go file by file, see what it looks like. Yeah,
it would be interesting to say, if you just go ahead and run it now, what does it give us? Does it say anything?
Well, when I played around with it, if you just add that TS check to a file, I was surprised by how many things it kind of raised. A lot of those, as Patrick was saying, maybe places where it's getting things wrong, inferring things wrong, but it definitely finds stuff to raise as things to look at. In my experience.
Okay, thanks. So we can't just turn it on right now. We would have to prepare to turn it on. Okay.
Yeah, I think so. I think it's a kind of gradual introduction type thing, and kind of fixing things up as you go to make sure they're working for the type checker.
Very good. Do we have anybody else who wants to weigh in? Last call. That looks like a no. So we should all give a round of virtual applause to Paul for his talk. Good job, Paul. Thanks for taking the time to give this excellent presentation.